So let's start with 2024 paper January session. Okay. First question, first का A. They said determine the power supplied by the source in the given network. तो ये 3 marks का question है. Power supplied by source, as you know, power का formula is V into I and will have power का formula is I square R. तो they said कि source से means 18 volt से, then in that case you have to use V into I. If they ask you power across resistor, then in that case you need to get, and then in that case you need to use I square R formula, right? So how will you get the current? By using mesh analysis. So after the second mesh equation is minus 6 I2 minus I3 minus 4 I2 minus 4 I2 minus I1 is equals to 0. Third mesh equation is minus 6 I3 minus 6 I3 minus I2 minus 6 I3 minus I1 is equals to 0. After solving all these three equations, we can get the current I1. Power supplied by the source means P is equals to V into I. Voltage is 18 volt and the current is I1. So substitute the value of I1 here and then you will get the power. Clear? Now see next question, first ka B. As I told you, according to the pattern ki one question will come from the mesh analysis, nodal, source transformation or star delta, and one question exactly you will get it from the maximum power transfer theorem, right? So in maximum power transfer theorem we'll have condition that load resistance must be equals to the Thevenin resistance. Okay, and तो ये लोड रेजिस्टेंस है तो ये दैट इज इक्वल्स टू थेवेनिन रेजिस्टेंस एंड मैक्सिमम पावर वी नीड टू कैलकुलेट फॉर दैट फॉर्मूला इज v स्क्वायर th डिवाइडेड बाय 4RL. तो सबसे पहले व्हाट वी नीड टू गेट दैट इज vth. फॉर गेटिंग vth RL मस्ट बी रिमूव्ड, राइट, एंड द सर्किट मस्ट बी ओपन सर्किट, करेक्ट, and mark terminal A and B over here. Now VTH would be equals to VAB, correct? Now tell me how we can get VAB. Just so if I'll solve the circuit, it would be moving from A to C, C to D, D to E, E to B, right? Don't think like current is moving. तुम ऐसे सोचो कि तुम मूव कर रहे हो, यू आर स्टैंडिंग एट ए, यू नीड टू मूव टुवर्ड्स बी. ए से सी जाओगे, सी से डी, डी से ई, ई टू बी, और यू कैन चूज द लॉन्गर पाथ ऑल्सो, right? That's up to you, but why would you choose the longer path that if shorter path is available? So for this we'll have the single mesh because ये तो open circuit हो गया. If you are moving from C to D, D to E, तो as I told you current should also move in the same direction. जिस direction में तुम जाओगे current would go like according to you only, right? So let's mark the sign if it is according positive, negative, right? As I told you, we have to take every time the second sign. If you are moving from A to C, then like I can write it down also, A to C, VAB is equals to VAC, VCD, VDE and VEB. A to C second sign is -2, C to D second sign is -3 into current is how much? I1 only because it's a single mesh. D to E second sign is -30. E to B no resistance, no battery, so it would be 0. So for getting VTH we need to get the value for I1, and whenever you need to get the value for I1 you always have to apply mesh analysis. So we'll have this single mesh, we can apply mesh analysis over there. That would be -3 I1 minus 30 plus 24 minus 6 I1 is equals to 0, right? तो ये कितना हो जाएगा? -9 I1 minus 6 is equals to 0, correct? So that would be -9 I1 is equals to plus 6 I1 would be equals to 6 by 9, minus only. So let's put the value of I1 over here, -2 -3 -6 over 9 -30, correct? So after solving these values, can we get the value for VTH? Now after that in the next step we need to calculate RTH, right? How we can get RTH? As you know, for calculation of RTH, what we need to do, voltage source must be short circuit, correct? And current source must be open circuit, correct? So resistance is there, voltage source must be short circuit, again resistance is there, voltage source must be short circuit, this one is also short circuit. Okay, so across A terminal and B terminal we need to calculate RTH. So as you can see clearly, we'll have only two resistance. Just imagine you are standing at A, you need to move towards B. So 6 and 3, according to you, they are in series or in parallel? Parallel. So that would be 6 parallel 3. So 6 into 3 divided by 6 plus 3. Okay. So that would be 2 ohm. What they are asking in the question, they ask you to calculate maximum power. So P max ka formula is V square TH divided by 4 RL. RL you calculated, that is 2 ohm. VTH you have calculated from here, whatever you will get the value. Solve it and then substitute it over here. Then after solving you will get the maximum power. Okay. So compared to other papers or other numericals, this numerical is easy. मतलब एक normal numerical है, ये भी मुश्किल नहीं है. तो ideally अगर तुम्हें थोड़ा बहुत भी BT आता है तो तुम्हें ये question आना चाहिए. Now next question, first का C, determine the power dissipated in 3 ohm resistor. So it's of 4 marks. तो how we can get the power across 3 ohm resistor? We'll have two option, one is mesh analysis and another one is nodal analysis. वो वाला question मैंने mesh से करवाया था, ये वाला मैं nodal से करवा देती हूँ. Ideally it should be according to nodal only. So power across 3 ohm resistor formula is I square R. Current we need to calculate, resistance is how much? 3 ohm, right? So current across 3 ohm we need to calculate, and I am calculating by using nodal analysis. How many nodes are there in this? This is one of the node V1, this is another node V2, and this is another node V3, correct? So let's mark the current as well. I1, I2, I3, I4, I5, I6. If current is given, you can take it according, you have to take according to the circuit, but agar current is not given, then you can take it according to your own also. Okay. Now apply KCL at node V1. Okay. So KCL states that sum of incoming current is equals to the sum of outgoing current, correct? So I1 would be equals to I2 plus I3. Now I1 is the current that is moving from 0 to V1, right? So it is moving from 0 to V1, so 0 minus V1 divided by the resistance 2. I2 is moving from V1 to V2, so it would be V1 minus V2 divided by the resistance, and I3 is moving from V1 to V3. We have to see from node to node, so V1 minus V3 divided by 2, correct? Now after that apply KCL. ऐसे तुम्हें प्रॉपर लिखना है, ठीक है? That you are applying KCL at node V2. Now this is for node V2. Next is apply KCL at node V3. So I3 and I5 are incoming current, I6 and I7 are outgoing current. I7 is how much? Minus 2. I6 is how much? V3 by 9. I5 you already know, V2 minus V3 by 3. I3 is V1 minus V3 by 2. So after solving these three equations, we'll get the value for V1, V2, V3. After getting V1, V2, V3, we can get the current across 3 ohm. That is I5, right? Current across 3 ohm is how much? I5 लिया हमने, and I5 is moving from V2 minus V3 divided by 3. So we know the value of V2, we know the value of V3, we can get I5 easily. and after getting the current we can substitute it over here, then we'll get the power. तो ये वाला क्वेश्चन भी easy ही है. Now question number second का A, and this is the transient based question of 3 marks. So see what they have said. The switch in the coil has been open for a long time. Okay, switch मतलब बहुत टाइम से ओपन है. Determine the current I1, I2 and I3 in the resistor and in the self inductance cell. इसमें हमें I1, I2, I3 निकालनी है just after the switch is closed. Okay, just after the switch is closed. तो initially like in this basically they have asked when the switch is closed then calculate the current, right? Just after the switch is closed means if the switch is closed then we have to calculate the current. Which current we need to get? That is I1, I2 and I3, correct? So when initially switch is closed then current through the inductor is changed due to a back EMF is produced, right? So basically whenever we'll have the circuit, तो I1 मुझे निकालना है. Suppose we can say I1. तो इससे पहले मुझे क्या निकालना पड़ेगा? IL of 0 minus, right? अगर तुम्हें याद है तो if you remember, as you know I told you IL of 0 minus would be equals to IL of 0 plus, right? So whenever we need to calculate IL of 0 plus, for that we need to get always IL of 0 minus, right? यही होता है. Because inductor doesn't change its current instantaneously. Inductor एकदम से अपने current को change नहीं करता. So first, as I told you always, for the transient based question, what you need to do in any kind of circuit, first you draw the circuit at t equals to 0 minus, and draw the circuit at t equals to 0 minus. If there is a question of inductor, then in that case you need to calculate IL of 0 minus. That would be equals to IL of 0 plus, correct? So as you can see that at t equals to 0, what they have said that at t equals to 0, switch is closed, right? So before t equals to 0 minus, switch should be open, yes or no? At t equals to 0 switch is closed, तो just उससे पहले क्या होगा? Open होगा. And if it's open circuit, that the current through the inductor should be 0 because there is no source of supply. If it's open circuit, then current won't be able to flow through inductor. So we can conduct that IL of 0 minus should be equals to 0, or we can say that IL of 0 minus is equals to IL of 0 plus, and that is equals to I3, that is equals to 0. यहाँ तक बोलो, any doubt? That we get current I3 is equals to 0. Clear? But it's not same for the resistor. At t equals to 0, the switch is closed, and if the switch is closed, तो that means कि current यहाँ से यहाँ जा रही है, क्योंकि ऊपर तो कुछ current जा नहीं रही, that is 0. So can we say that at t equals to 0, I1 is equals to I2? Yes or no? So for that I'm redrawing the circuit that at t equals to 0, if the switch is closed, the circuit would be like this. This is R1, this is R2, this is V, and पहले उसमें ऊपर करंट नहीं जा रहा है, तो that means t equals to 0 में भी नहीं जाएगा, that was 0. So now we need to calculate I1, and now we need to calculate I2. So from here we can conclude that I1 is equals to I2, and according to Ohm's law, that is V by R. Total voltage is V over here, resistance is R1 plus R2. So up to here we got the three values. क्या? Because they didn't mention the values ना, तो we have to calculate in terms of this only कि I3 is equals to 0 and I1 is equals to I2 is equals to V divided by R1 plus R2 ampere. Now after this, in the second part, they said a long time after the switch is closed, means after switch the close, there is a long time passes. So that means that is the time of t equals to infinity. Can we say it like this? that switch is closed, and then long time passes, that means the time is equals to infinity. The internal resistance of the battery is negligible. Express your answer in terms of V, R1, R2 and R. Express your answer in terms of V, R1, R2 and L. Means they are asking the value of I1, I2 and I3 again, but at the time t equals to infinity. ठीक है? Basically they are asking I1, I2 and I3 just after the switch is closed, means at t equals to 0, and for the long time means t equals to infinity. Now as you know, now we need to draw the circuit at t equals to infinity, and as you know that t equals to infinity is the steady state condition, right? And remember I told you in the steady state condition inductor will behave like a short circuit, correct? So if I'll redraw the diagram, resistor as it is, switch is closed and will provide the battery, and inductor will be short circuit, correct? Now this is the diagram, and in this particular diagram we need to get I3, we need to get I2 and we need to get I1. So as you can see कि current यहाँ से चल रहा है, so current have two option. It has two option means कि either it can move through the resistance वाला path or it can move through the plane path. So which option he'll choose? He'll always move through the plane path. Like suppose I'm giving you example, you are riding a car, okay, and you have two paths, one path with lots of hurdles and one path with a plain road. So which path you will follow? प्लेन रोड वाला ना. सो इट्स सिमिलर टू लाइक करंट के पास टू ऑप्शन है. करंट ऑलवेज फॉलो द लीस्ट रेजिस्टिव पाथ मीन्स द प्लेन वायर पाथ. सो दैट means I2 is equals to 0 and I1 is equals to I3, and I1 is equals to I3 is how much? That is V divided by रेजिस्टेंस. कौन से रेजिस्टेंस से ये जा रहा है? R1 से जा रहा है. सो V डिवाइडेड बाय R1. तो इसका आंसर है ये, दैट इफ एट t इक्वल्स टू इन्फिनिटी I2 0 है और I1 और I3 की वैल्यू सेम है V बाय R1. वाई आई एम नॉट टेकिंग R2? बिकॉज वहां से करंट जा ही नहीं रहा. गॉट इट? मार्क दिस क्वेश्चन एज इम्पॉर्टेंट. ओके, सो अगर ट्रांजिएंट में तुम्हें कुछ भी समझ में ना आए तो व्हाट यू नीड टू डू, ड्रॉ सर्किट एट t इक्वल्स टू 0 माइनस. इंडक्टर का केस है तो कैलकुलेट IL ऑफ 0 माइनस. कैपेसिटर का केस है तो कैलकुलेट VC ऑफ 0 माइनस. वट एवर दे लास्ट, अगर कुछ भी ना समझ में आए तो सो ड्रॉ द सर्किट एट t इक्वल्स टू इन्फिनिटी. अगेन इंडक्टर का केस है तो कैलकुलेट IL ऑफ इन्फिनिटी. वोल्टेज का, कैपेसिटर का केस है तो कैलकुलेट VC ऑफ इन्फिनिटी. देन ड्रॉ अ सर्किट एट t इक्वल्स टू 0, कैलकुलेट टॉ, एंड देन जो मैंने फाइनल वोल्टेज निकाला. मतलब जैसे जैसे आई टोल्ड यू द स्टेप्स ना, व्हेन आई टोल्ड यू द ट्रांजिएंट, सेम स्टेप्स डू इट. कुछ भी नहीं समझ में आया तो कुछ तो मैच करेगा, राइट? गॉट इट? नाउ विल गेट टू क्वेश्चन फ्रॉम द मैग्नेटिक, 4 marks. A ring formed. Suppose let's draw the diagram. There is a kind of ring, okay. A ring formed. A magnetic material is made from two material. So this ring is made up from two material. This is, suppose, consider the material A. Like मेरे से diagram अच्छा सा नहीं बना. And this is material B. Okay. So permeability, whatever they have given, write it like this. Mu r is given 2000. Length is given how much? 25 centimeter. So 25 centimeter है तो 25 into 10 raised to power minus 2 meter. Area is given 4 centimeter square. 4 centimeter means 4 into 10 raised to power minus 4 meter square. And the remainder cast iron relative permeability. तो ये पहले वाले केस का है. For the another material permeability is 1350 and उसकी length is 20 centimeter means 20 into 10 raised to power minus 2 meter, and area for another case is 7.5 centimeter square. That means 7.5 into 10 raised to power minus 4. Determine the total mmf to cause a flux of, flux is given 0.30 milliweber. Milliweber means 0.30 into 10 raised to power minus 3 Weber. तो we have to calculate the total MMF. So MMF का फॉर्मूला if you know, तो MMF का फॉर्मूला होता है, हर बार इसी टाइप का you will get the question. MMF का फॉर्मूला is N multiplied by I is equals to phi into S. N is the number of turns, I is the current, phi is the flux and S is the total reluctance. ठीक है, तो what we need to get MMF, तो हम कहाँ से निकाल सकते हैं, बाय यूजिंग दिस फॉर्मूला phi into s. नंबर ऑफ टर्न्स वगैरह नहीं दिया हुआ तो वो नहीं, वी कैन यूज phi into s. सो फॉर दैट phi is given but we need to get s, right? So how we can get s, we'll have two reluctance हैं, तो दोनों reluctance we need to calculate. Reluctance का फॉर्मूला as you know, for the first material L divided by mu naught mu r into area. For this one S2, L divided by mu naught mu r into area. There is no air gap given, तो कोई बात नहीं. So just you need to put it down the values. 25 into 10 raised to power minus 2. Mu naught is 4 pi into 10 raised to power minus 7. Mu r is given 2000. Area is given 4 into 10 raised to power minus 4. ठीक है? Clear? So we can get the second reluctance also, just you need to substitute the value, and after getting this phi we know, reluctance is added S1 plus S2, तो दोनों को ऐड कर देना. flux we know, we can get MMF easily. ये वाला क्वेश्चन भी easy ही है, 4 मार्क्स में है, and they ask to calculate total reluctance also, वो तो हमें already निकालना ही है. Got it? Clear? Magnetic say will always get 2 question हमेशा. One is based on this and another one is based on dot coupling or self inductance. तो ये वाला क्वेश्चन थोड़ा सा मुश्किल हो जाता है, बट सेल्फ इंडक्टेंस वाला क्वेश्चन लाइक दिस काइंड ऑफ वो इजी होता है. वो नहीं समझ में आ रहा तो वो छोड़ दो, ये वाला क्वेश्चन जरूर पढ़ के जाना. Now see, 2 coils are connected in series. We'll have 2 coils that are connected in series. The total inductance is 250 millihenry. L equivalent is how much? 250 millihenry means 250 into 10 raised to power minus 3 henry. When connected in a series opposing configuration, these are 2 inductor, they are connected in opposing configuration. They are in series, तो इसका formula is L1 L2. तो इस केस में equivalent का formula is L1 plus L2 plus 2m. And in this case formula is L equivalent L1 plus L2 minus 2m. Okay, इसके केस में L equivalent is 150 millihenry. If the inductance of one coil is 3 times of the other, तो इस exactly इसी statement से equation बनाओ. If the inductance of one coil, let us consider L1 is means equals to 3 times means 3, the other coils is S2. So we'll get one more equation, that is L1 is equals to 3L2. Find the self inductance and the mutual inductance and coefficient of coupling. तो पहले बताओ, we'll have 3 equation. 3 equation आ गई ना. One is equation is this one, another equation is this one, L1 plus L2 plus 2m is equals to 250 millihenry. L1 plus L2 minus 2m is equals to 150 millihenry, right? 3 equation है और 3 ही variable है. Can we get the value for L1, L2 and m? See, we'll have these 3 equation. L1 plus L2 plus 2m is equals to 25 millihenry, right? Next equation is L1 plus L2 minus 2m is equals to 150 millihenry, correct? Then after, how we can solve this equation? Can we add these 2 equation? So after adding these 2 equation, cancel. So that would be twice of L1 plus L2 is equals to 25 plus 150 millihenry. So we'll get L1 plus L2 is equals to 175 divided by 2, and we'll have the third equation, L1 is equals to 3L2. So we can substitute it over here, that 3L2 plus L2 is equals to 175 by 2. Then we'll get L2. After solving, we'll get L1. We can substitute in any one of the equation, then we'll get M. Correct? Now we need to determine the coefficient of coupling. Coefficient of coupling means we need to get K, and what is the formula for that? K is equals to M divided by root of L1 L2. So write it down all these formulas in your notes. First formula for the series, second formula for the opposing, third formula for the coefficient of coupling. Okay, if we know the value of M, if we know the value of L1 and L2, can we get the coefficient of coupling value easily? ये क्वेश्चन भी इजी ही है तुम्हारा. सॉरी, इट वाज 250 मिली हेनरी, तो इसके अकॉर्डिंग वैल्यूज चेंज हो जाएगी. ठीक है, वो कर लेना. इट वुड बी 400 by 2, दैट वुड बी 200. Okay, see in this question they said determine the impedance between A and B. Okay, impedance means the Z equivalent. As you can see that Z1 is connected in parallel with Z2, so that would be 8 plus J10 multiplied by 7 plus J9 divided by 8 plus J10 minus, sorry, plus Z1 plus Z2 होता है ना, 7 minus J9, right? By using complex method in the calculator, you can solve it directly, rectangular to rectangular multiplication that I told you. Plus Z3. Z3 is 5 minus J2. So after solving it, we can get Z equivalent. Correct? Now they are asking the power factor. So power factor is what? Power factor is the cos phi, and for that we need to get phi. So remember I told you, write it down also. Whenever we'll have series circuit and we need to calculate cos phi, then we'll use R by Z formula. But whenever we'll have the parallel circuit and we need to get cos phi, how we can get phi? We need to get the phi value only. For that, what is phi? Phi is the angle between voltage and current, or whatever the impedance angle you'll have, that is phi. ठीक है? So in this case you'll get the total impedance Z equivalent. तो इसका will have some angle ना, तो वो क्या होगा? phi होगा. ओके, टोटल इम्पिडेंस का एंगल इज फाई, तो फाई यहाँ पे सब्स्टिट्यूट वी कैन, एंड देन विल गेट द power factor. So this is more and more important. So now we get cos phi also. Then we need to calculate total power consumed. Okay, so power का formula is VI cos phi. Voltage is 200. एक चीज और, that never take angle. Okay, never take angle in calculation of power. यहाँ पे 200 angle 30 नहीं निकल रहा, only 200. Current we can get it by the formula of V by Z. V they have given, Z you know, we can get the current. Put the magnitude of the current, and power factor you already calculated. After substituting, you will get the value for power, and active power unit is what? Don't forget to mention units. Okay, half marks Manipal teacher can deduct it to you. Now see, this is also the parallel circuit based question. In a single phase AC circuit, the two parallel branch means we'll have two parallel branch. This is A and this is B. Both are connected in parallel like this, and in series with C means A and B are connected in series with C. The branch impedance ZA is 8 plus J6. Okay, that means it is the combination of R and L. 10 minus J8, that means it is the combination of R and C. Voltage across, ये नहीं पता हमें क्या है, because they didn't provide कि क्या है, but they have provided the voltage. Voltage across C is how much? 58 volt. अब देखो स्टूडेंट्स क्या करेंगे, ध्यान से अगर जल्दी जल्दी में पढ़ लेंगे तो वो इसको क्या ले लेंगे, 58 plus J0, है ना. क्योंकि वो तरीके उसी तरीके से ही दिया हुआ है। अगर 58 देंगे तो इतना ध्यान नहीं जाएगा, 58 प्लस J0 स्पेशली मेंशन करा हुआ है, तो उन्हें लगेगा, बच्चों को लगेगा यहाँ पे वो 58 प्लस J0 लिख देंगे, नहीं, बट दिस इज द वोल्टेज एंड ये है। नाउ यू नीड टू गेट IA, IB and IC. Now tell me how we can do it. Now see, एक चीज और, write it down in your notes. Whenever you will have parallel circuit का क्वेश्चन, तो सबसे पहले तुम्हारे माइंड में आना चाहिए CDR. CDR is current division rule. If you know about it, current division rule, तो best है. Otherwise I'll tell you, like suppose this is 4, 6, 8 and 10 volt. Suppose this is the current I ले लेते हैं total current, this is I1 and this is I2, and we need to calculate the value for I1 by using current division rule. तो उसका formula is total current multiplied by the opposite resistance 8 divided by the sum of resistor which are connected in parallel, 6 plus 8. Similarly I2 is how much? Total current I multiplied by the opposite resistance 6 divided by 6 plus 8, right? तो इधर आ जाओ, we'll have impedance for C, we'll have voltage for C. Can we get the current for C? IC is equals to VC by ZC. VC is 58 plus J0 and ZC is 44 plus J2. Can we get the IC value directly? सॉल्व कर लेना, कैलकुलेटर में डायरेक्टली हो जाएगा इन द कॉम्प्लेक्स मोड, राइट? आफ्टर गेटिंग IC we need to get IA. So by using current division rule we can get it easily. Formula for IA is total current. Total current is IC multiplied by the opposite resistance. So IA के opposite resistance is 10 minus J8, right? Divided by the sum of resistor which are connected in parallel. So sum is 10 minus J8 plus 8 plus J6. ठीक है? Similarly we'll get IB. IB is how much? IC opposite resistance. Opposite resistance is 8 plus J6 divided by sum. Sum कितना हो जाएगा? 10 plus 8 is 18 minus J2. So after solving all these values we can get current IA, IB and IC, right? और इनके साथ इनके एंगल्स भी आएंगे. तो दे आर आस्किंग, पहले वाले में दे हैव आस्क्ड यू द मैग्नीट्यूड ऑफ IA, IB, IC. सेकेंड पार्ट में दे हैव आस्क्ड यू द एंगल ऑफ IA, IB, IC. नहीं, फेज एंगल बिटवीन IA एंड IB, IA एंड IC अलग अलग पूछा हुआ है. मैं वैल्यू लेके बता रही हूँ. लाइक विल गेट सपोज करंट IA की वैल्यू, मैं रैंडमली वैल्यू ले रही हूँ, ये वाली वैल्यूज नहीं आई. लाइक सपोज IA की वैल्यू आई है 2 एंगल 30 एंड IB की वैल्यू आई है 5 एंगल 40 डिग्री. ओके, नाउ यू नीड टू गेट फेज एंगल बिटवीन IA एंड IB. तो IA और IB के बीच का एंगल डिफरेंस कितना होगा, खुद बताओ. ये क्या हो गया? सपोज ये क्या हो गया? 0 डिग्री, 30 डिग्री यहाँ पे, 40 डिग्री यहाँ पे. तो इन दोनों के बीच का एंगल डिफरेंस इज 10 डिग्री. ठीक है. इसी तरह सपोज IC का आ रहा है 3 एंगल -90, माइनस ले लिया मैंने. एंड देन नाउ यू नीड टू कैलकुलेट द एंगल बिटवीन IB एंड IC. देखो 0 डिग्री हेयर, 40 डिग्री हेयर एंड -90 डिग्री हेयर. दिस इज फॉर IB, दिस इज फॉर IC. तो नाउ टेल मी IB और IC के बीच का एंगल इज हाउ मच? 90 प्लस 40. ठीक है, ऐसा नहीं है कि सब्ट्रैक्ट होगा. फेजर डायग्राम यू हैव टू ड्रॉ ऑन द बेसिस ऑफ फेजर डायग्राम ओनली यू कैन जज कि प्लस होगा माइनस होगा. गॉट इट? बट दे हैव आस्क्ड टू यू. Now in this question they said in the arrangement shown wattmeter reading. Wattmeter reading means power is given. Okay, 1.5 kilowatt, and ammeter reading means current is given 9.615. Calculate the value of shunting capacitor to raise the power factor to unity. So for this particular value voltage is also given 240 volt and frequency is also given. We need to get cos phi. ठीक है, whenever we'll need जब हमें पुराना cos phi पता होगा then only we can improve to unity now, right? So we'll have formula P is equals to VI cos phi, power is 1.5, voltage is 240, current is 9.615. Can we get the value of cos phi from here? After solving we'll get cos phi is 0.65. ठीक है, so now write it down in your formula sheet. Whenever you'll have the question of power factor improvement or power factor correction, okay, so we'll follow the same steps every time. Draw two power triangle, one is without improvement and another one is with improvement. Okay, so without improvement, let's mark P1 Q1 S1. This one would be P1 Q2 S2. Why I have take P1? Because without improvement and with improvement active power is also always same. ठीक है, तो cos phi का फॉर्मूला इज P1 by S1, उल्टा लिख दिया मैंने, सॉरी, S1 और Q1 यहाँ पे आएगा, S2 एंड Q2 यहाँ पे. सो पावर फैक्टर cos phi is equals to P by S है ना, बेस बाय हाइपोटेन्यूज. इफ विल गेट द वैल्यू फॉर P1 S1 and Q1, similarly we'll get the value for P1 S2 and Q2, then we'll have formula Q1 minus Q2 is equals to V square by XC. तो अब क्वेश्चन पे आ जाते हैं. लाइक विदाउट इम्प्रूवमेंट द पावर फैक्टर इज 0.65, सो 0.65, एक्टिव पावर इज गिवन 1.5 किलोवाट, मींस 1.5 किलोवाट डिवाइडेड बाय S1, राइट? कैन यू गेट द वैल्यू ऑफ S1 फ्रॉम हियर? And after getting the value of S1, can we get the value for Q1? Tell me. Now Q1 आ गया, basically we want Q1. Okay, now for this case cos phi is equals to 1. Why is it so? They said in the question, calculate the value of shunting capacitor. Shunting means with the load, capacitor is connected in parallel. Parallel means shunt. To improve the power factor to unity. Unity means कि now power factor is unity, means 1. So cos phi is equals to 1 means P1 is equals to S2, right? P1 दिया हुआ है 1.5, S2 is 1.5. इसको solve कर लेना, then you will get Q2 is equals to 0, correct? So now we'll have Q1, Q2 is 0. Voltage they have given in the question, always voltage वो हमेशा देंगे 240 volt. तो 240 का square divided by XC. Q1 we can substitute it here. Can we get the value of XC from here? ये बताओ. Q1 हमने पहले वाले पावर ट्रायंगल से निकाल ली. All the values are known. Can we get XC? And after getting XC we need to get C. As you know the formula of XC is equals to 1 by 2 pi FC. तो C की value we can get. Frequency is also given 50 Hertz. Correct? Now they are asking obtain the new ammeter reading after power factor correction. Means for this particular triangle they are asking the current. So we'll have the formula of P is equals to VI cos phi. Power is 1.5, voltage is 240, current we need to get it. Cos phi after improvement is 1, right? Cos phi की value unity है 1 है. So I is how much? 1.5 into 10 raised to power 3, because it is measured in kilowatt. Kilowatt में दिया हुआ है वो, divided by 240. After solving it we'll get the value for current. Now next question, 3 similar coil, resistance is 7 ohm and inductance is 0.03 Henry. So we can get XL from here by using formula 2 pi FL. 2 we know, pi we know, 50 Hertz frequency we know, L we know. So we can get ZPH from here, that is R plus JXL. So 7 plus JXL, right? After solving, we'll have delta connection. Delta means line voltage must be equals to phase voltage, and current is IL is equals to root 3 of IPH. So we'll have formula VPH is equals to IPH into ZPH. So whatever the voltage they have given, that voltage is always the line voltage. So line voltage is 400, that is equals to phase voltage. IPH we can get it, ZPH is 7 plus JXL. ठीक है, IPH आ जाएगा. IPH line current पूछा हुआ है, तो IPH is IL is how much? Root 3 into IPH. Then you need to calculate active power, reactive power and complex power. Active power का formula is root 3 VL IL cos phi or 3 VPH IPH cos phi, and its unit is watt. Cos phi कैसे आएगा? Cos phi का formula is R by Z. R दिया हुआ है, they have given you 7 ohm. Z you can get it by the formula root of R का square plus XL का square. यहाँ से मैग्नीट्यूड आ जाएगा, या यहाँ से रेक्टेंगुलर से डायरेक्ट पोलर में कन्वर्ट कर लेना तो मैग्नीट्यूड आ जाएगा. मैग्नीट्यूड ही लेना यहाँ पे, बस एंगल नहीं लेना, ठीक है. And similarly you will get reactive power root 3 VL IL sin phi, and apparent power, complex power, basically जब भी they'll ask you the complex power, that is S is equals to P plus JQ. okay, तो उस केस में क्या फॉर्मूला होता है? P plus JQ. इस तरह से शो करना है. P you have already calculated, Q you have already calculated, तो you have to write it down in this form. Directly S को तुम root 3 VL IL करके आओगे तो उसमें मार्क्स नहीं मिलेंगे. Whenever they'll ask you the complex power. Got it? Now after that, last question of 3 phase. ये भी इजी है. देखो, अगर ओवरऑल देखा जाएगा तो तुम्हारा पेपर इजी ही आया है. इट्स नॉट काइंड ऑफ दैट डिफिकल्ट, राइट? इजी ही है. बस एक वो ट्रांजिएंट का क्वेश्चन इन्होंने अलग से दिया हुआ है, और बाकी पूरा पेपर अकॉर्डिंग टू द पैटर्न ही है. एंड मेकअप भी नहीं है, मेकअप एग्जाम भी नहीं है, नॉर्मल एंड टर्म एग्जाम है, राइट? तो नाउ रीड दिस क्वेश्चन. वॉटमीटर का फॉर्मूला वॉटमीटर पे बेस्ड है ये. When connected to delta connected load, 2 wattmeter produces wattmeter reading, means W1 is 1560, W2 is 2100, voltage is 220. Calculate power factor. Power factor का क्या फॉर्मूला होता है? root 3 tan inverse. But anyways, Manipal के according ये formula है. It's present in your handbook, so you don't need to finally learn this formula. Okay. So W1 value we have, W2 value we have. We just need to substitute it over here. Now they're asking per phase average power. So active power का formula is what? W1 plus W2, that is equals to root 3 VL IL cos phi. तो root 3 we know, VL we know, cos phi we know, but we don't have IL. तो पावर यहाँ से आ जाएगा. After that we can get IL, right? Then they are asking reactive power. Reactive power is root 3 VL. अच्छा sorry. They have asked per phase. तो per phase में ये हटा देना root 3. सिंगल फेज का पूछ लिया ना इन्होंने. ओवरऑल सिर्फ ये बोलते कि एक्टिव पावर बताओ तो रूट 3 लगता, बट नाउ दे हैव मेंशन पर फेज. तो VL IL cos phi एंड VL IL sin phi. phi पता है तो वी कैन गेट sin phi एंड वी कैन गेट रिएक्टिव पावर. IL नहीं पता तो IL वाला फॉर्मूला ऊपर से आ जाएगा, वैल्यूज ऊपर से आ जाएगी. देन वी कैन सब्स्टिट्यूट इट ओवर हियर. गॉट इट? Now last 2 question. Operation of transformer means working principle, and EMF induced. EMF induced का formula is E2 is equals to 4.44 N2 F5M. And single line diagram in the last paper I told you exactly इसी type का question आया हुआ है, right? So as I told you कि last वाले module में will have fixed question, वो ही fixed question every time they'll provide it to you, right? So up to here 2024 का paper is completed. Okay, so if you have any doubt you can contact me on this number, and if you want to take coaching of BTB or any another subject of Manipal, mainly B.Tech first year, then also you can contact me on this number. Thank you. Bye bye.